Now I want to talk about slope of a straight line. So here's what we're going to be talking about in this section. Slope is used to describe the steepness of a line, okay? So lines that are going uphill have positive slope, downhill have negative slope, horizontal lines have no slope, right? If I was to put a ball on it, it wouldn't roll either way, but this ball would roll downhill, and this ball, well, it would roll uphill. You kind of get the idea. So for vertical lines, the slope is undefined, and when we talk about how to calculate slope, this will become more clear. So the first thing I want you to do, though, is think about when something is undefined. Well, remember, a number is undefined if you had to divide by 0. Can you divide by 0? No. This does not exist. We calculate slope by looking at the ratio of vertical change, which is our rise, over our horizontal change, which is our run. So given 2 points on our line, we've got A and B and C and D. What we would do is we would take our vertical change, which is our 2 y's, and subtract them. So I'd take D minus B. And we'd take our 2 x's and subtract them. So I'd take C minus A. Okay, so this is our slope. So in this case, my rise is 3. So I would have a slope of 3 over 1, which we would simplify down to 3. So what is the slope? Wow, I can't spell. There. What is the slope of the line that goes through when x is 2, y is negative 1, and when x is negative 4, y is 3? So I like to label these x1, y1, and x2, y2. And I'm going to take my y's, so I'm going to take 3 minus a negative 1, and it's important to remember it's a minus symbol over here. So you need to put that negative in parentheses, so it'll cancel out to be a positive. Then I have x sub 2, so negative 4, minus 2, 3 plus a negative 1, that gives me a positive 4. Negative 4 minus 2 is a negative 6. And I can simplify this fraction, can't I? I can simplify it to 2 over negative 3. Now, where we're going, I highly recommend leaving it as a fraction. Do not convert to a decimal. We're going to use some of the properties of slope to make our lines easier to graph. So for now, do not convert to a decimal. Thanks. That's my little public service announcement. Okay, what is the slope? Wow, I still can't spell. What is the slope of the line that goes through 1, 4 and 5, 2? So let's go ahead and label our points. So my slope is my y values, 2 minus 4, which is my rise, over my run, which is 5 minus 1. So I have negative 2 over 4, which will give me negative 1/2. So simplify, but don't convert it to a decimal. Now, what is the slope of the line that goes through these 2 points? Let's go ahead and label them, because it's always nice to stay organized. I'm going to take my y's, which are 6 minus 3, over negative 2 minus a negative 2. That simplifies down to 3 over 0. Help! Okay, can I divide by 0? No! So this slope is undefined. What does that tell me? That tells me that this is a vertical line. Oops. And it's the vertical line when x is negative 2. And feel free to sketch this out, and that might make it a little easier for you to see. But when I have a graph of a vertical line, right, its equation is going to have the form x equals a, where a is a real number, because remember we're working on the real number line. And we say it's got undefined slope because in order to calculate it, we had to divide by 0. So this, for example, right here, this is the line x equals 3. Okay, now why don't we try and calculate the slope through these 2 points? Labeling our pieces to stay organized. Make that look like a 2. So I'm going to take 3 minus 3 divided by negative 4 minus 2. That gives me 0 divided by negative 6, which is okay. We can divide 0 by real numbers. Okay, so I'm left with a 0. If the slope is 0, this is going to be a horizontal line. This is the line y equals some constant. In this case, y is 3. So let's take a look at that on the next slide. Still can't spell slope. Sorry about that. So here is the form of a horizontal line. I have, in this case, y equals b, and that's always going to be the form it has. We say it has 0 slope because when we calculate its slope, that's the answer we get. Also, it's flat, right? It's parallel to the x-axis. For example, this equation would be when y equals 5. We can use our slope to graph lines. And let me show you how this works. So I want to graph a line through the point 3, 1 with slope of negative 4. So why don't I go ahead and graph the point 3, 1. So when x is 3, y is 1. It's going to go right here. Now my slope is rise over run. How can I write any constant as a fraction? Any integer or whole number as a fraction. I can put it over 1, right? Because negative 4 divided by 1 is still negative 4. Some things I also want us to keep in mind are this slope is negative. That means it's going to look like it's going downhill, right? So in this time, I don't really have a rise, right? I'm not going up a positive 4. I'm actually going down 4. And then my run is always in the positive direction because it's positive 1 over 1. Let me do that again. I can go down 4 because my slope is negative 4. And my run is 1, so I go over 1. So the big circles are actual points. If I wanted to go the other direction, I could also do the converse of this, right? I could go up 4 over 1, right? Up 4 over 1. And this would give me more points on my line. It's important to note, again, you only need 2 points in order to graph a line, but sometimes it's nice to find extra points. Okay, so here's the graph of the line through the point 3, 1 with a slope of negative 4. Now, what if I want to graph the line with a slope of 2/3, so that's positive slope, and a y-intercept of when x is 0, y is negative 4. Why don't we go ahead and plot this point? So when x is 0, y is negative 4. Here we go. And I have the slope of 2/3. So that means my rise is 2 and my run is 3. This slope is positive, so it's going to look like it's going uphill, right? So we're going to rise up 2 over 3. Up 2 over 3. Well, what's the opposite of up 2 over 3? Because I've ran out of points to find. I could go down 2 over 3. Okay, kind of the opposite. And that would also help me find another point on my line. So here I have the line with slope of 2/3 and y-intercept when x is 0, y is negative 4. We've only, so far in this chapter, been looking at equations in standard form. But we have another form of linear equations that's a lot easier for us to kind of look at and visualize what our graph looks like from that, and that's going to be the slope-intercept form of a line. So what this does is this, if we solve for y, we're going to get a slope of m, and our y-intercept is b, okay? And in order to do this, we're going to solve any equation for y. So I'm going to go ahead and take the standard form and solve for y just to get us a little more comfortable working with way too many variables. So the first thing I need to do is get y all by itself. So I'm going to take negative ax from both sides. That gives me by equals negative ax plus c. And in order to get y by itself, I need to divide both sides by b. So I have y equals negative a over bx plus c over b. Let's do some not so variable heavy examples, shall we? So let's find the slope-intercept form of, let's start out with 8x minus 4y equals 4. So the first thing I'm going to do is isolate y, right? Because we want it to look like y equals mx plus b. So I subtract 8x from both sides. That gives me negative 4y equals negative 8x plus 4. To get y by itself, I divide both sides by negative 4. That gives me y equals negative 8 divided by negative 4, which is a positive 2. X, 4 divided by negative 4 is going to be a negative 1. So I have y equals 2x. Now let's look at what we've learned about this linear equation since we switched its form. So if we looked at it before we simplified it, do we know anything about what this graph looks like? Does it have positive slope? Does it have negative slope? Does it have no slope? Well, of course it doesn't have no slope because it has an x, but that's okay, right? We can't really visualize what this linear equation looks like. Once I'm given the slope-intercept form, I know that this line has a positive slope. Its y-intercept is negative 1, so its y-intercept is just a little below the origin. Okay, that's a lot. I can now visualize, and hopefully you continue to do this as this chapter goes on. I really suggest you visualize what you are doing. Visualize what your graph looks like. Sketch a little graph. It doesn't have to be anything great. Look, let's sketch one. Okay, so I have a line, it's negative 1, and its slope is up 2 over 1. Up 2 over 1, right? This is like a good guess. You should probably try not to miss your points. But like just a little sketch so you know where your y-intercept is and slope and everything like that. It's a great way to make more connections between the equations and what their true representation means, right? So now I'm going to go ahead and do problem part B. Again, I need to isolate y, isolate the variable. So I subtract 5x from both sides. That gives me 2y equals negative 5x plus 7. I'm going to go ahead and divide both sides by 2. That means y equals negative 5 halves x plus 7. So now I know this line has a negative slope. It has a rise of negative 5, a run of 2, and a y-intercept of 7. I would not recommend switching your slope to a mixed number, right? We don't want to write this, we don't want to write this as negative 2 and 1/2, right? That doesn't really tell us how to graph it, right? This way we know to go down 5 and over 2.